You've probably seen them 1,000 times. Maybe you've even walked on them. Railway tracks sit on top of a bed of small, rough stones. Not dirt, not concrete slabs. Stones. Why? It seems like an odd choice. Train tracks are heavy steel beams carrying massive locomotives. So why would engineers choose to rest all that weight on something as simple as crushed rock? The answer is smarter than you think. And once you understand it, you'll realize these stones are doing four incredibly important jobs all at once. Let's start with the most obvious one: support. A fully loaded freight train can weigh thousands of tons. All that weight is concentrated onto two narrow steel rails. If you place those rails directly on dirt or pavement, the ground would compress, shift, or sink over time. The tracks would warp, the train would derail. So engineers need something that can spread that enormous weight out evenly across a wider area. That's exactly what the stones do. They're called ballast, and they act like a cushion that distributes the pressure from the rails down into the soil below. Instead of two thin lines of force, you get a broad, stable foundation. But here's where it gets interesting. The stones don't just sit there holding weight. They also drain water. Imagine what would happen if the track bed was solid. Rain would pool underneath the rails. Water would soften the soil, create mud, and destabilize everything. In winter, that water could freeze, expand, and crack the foundation apart. The stones solve this beautifully. Because they're loose and irregularly shaped, water flows right through the gaps between them. Rain drains away quickly. The track bed stays dry. The foundation stays firm. No erosion, no frost damage, just simple, passive drainage that works every single day without any moving parts. Now, here's something most people never consider. Trains are loud. And when a heavy train barrels down the track at high speed, the rails vibrate intensely. If those vibrations transferred directly into the ground, they'd crack pavement, damage nearby structures, and create unbearable noise for anything close to the tracks. The ballast absorbs those vibrations. The stones shift slightly under pressure, damping the energy instead of transmitting it. It's like the difference between dropping a weight on concrete versus dropping it on gravel. The gravel gives a little, it softens the impact. The stones do the same thing for every passing train. But there's one more reason these stones are genius, and this one might be the most important of all. Railway tracks need constant maintenance. Over time, the rails shift, the ground settles, the track alignment drifts just slightly out of place. If the track bed was poured concrete or asphalt, fixing that would require jackhammers, excavation, and weeks of construction. With ballast, it's simple. Workers can lift the track slightly with hydraulic jacks, add or remove stones, and adjust the alignment in minutes. The stones are loose. They're movable. They let engineers tweak and correct the track without tearing everything apart. In fact, there are machines called ballast regulators that travel along the rails and automatically redistribute the stones to keep everything level. It's maintenance-friendly engineering at its best. So, what seems like a pile of random rocks is actually a brilliantly designed system. The ballast supports massive weight, drains water constantly, absorbs shock and vibration, and makes the entire track easy to adjust and repair. It's simple, it's cheap, it's effective. And it's been working for over a century because sometimes the best solution isn't the most high-tech one. It's the one that quietly does four jobs at once without ever asking for attention. Next time you're waiting at a railroad crossing, take a closer look. Those stones aren't just sitting there. They're holding up one of the most essential transportation systems in the world, one small rock at a time.